Welcome back to part 4, to section 4.7. So we're going to be looking at still more of these inverses. So if we're looking at the arc sine of x, the domain goes from -1 to 1. So that means the domain is defined on the interval from -1 to +1, including those. Oh, sorry. The domain is defined on the interval for the sine of x. It goes from -π/2 to π/2. Remember, we're restricting ourselves in those two quadrants. And then our range would go from -1 to 1. For cosine of x, we're going from 0 to π. We're in quadrants 1 and 2. -1 to 1 is our range. And for tangent, we're going from -π/2 to π/2. Now for that one, for tangent, because the graph of it, it's all real numbers for the range. So really what we want to think about. For sine, we're working in quadrants 1 and 2. 1 if it's positive, or sorry, 1 and 4. 1 if it's positive, 4 if it's negative. We can't take the inverse sine or arc sine of anything greater than 1 or less than -1. It's got to be between -1 and 1. For cosine, when we take the inverse, we're in quadrants 1 and 2. 1 if it's positive, 2 if it's negative. Once again, we can only take the inverse sine or arc cosine of numbers between -1 and 1. If it's greater than 1, it can't do it. If it's less than -1, we can't do it. Now for tangent, we're looking in quadrants 1 and 4. 1 if it's positive, 4 if it's negative. And we can find the arctangent of any number. We can find the arctangent of any number. Now, as we talked about before, the inverse trig properties, when you take the inverses, the sine of the arc sine, you get x. They undo each other. The arc sine of the sine, they undo each other. Those are the inverses. That's how we get rid of them, is by taking the inverses. So let's go to the next page and do some examples. The tangent of the arctangent. They undo each other. We're at -5. And there's our answer. Now the arc sine of the sine of 5π/3. Now we do get 5π/3, but 5π/3 is a little bit too big for us. So what we have here is, if you think about where 5π/3 is not in the range. We need to be between π/2 and -π/2. Now 5π/3 is over here. 5π/3 is over here. So what we can do is we can look at this angle here to get us in the quadrant 3. 5π/3. So we can do for number 25, the arc sine of the sine of 5π/3. Now they're going to cancel each other out, but if we think about it, 5π/3 is outside of our range, our domain, excuse me, range. We want to look only between -π/2 and +π/2 for sine. If we were to graph 5π/3, 5π/3 is all the way over here in quadrant 4. Now, its reference angle for 5π/3. So if we do 2π minus 5π/3, we get 6π/3 minus 5π/3, which is π/3. But to be in quadrant 4, we're going to be, our angle theta is -π/3. So this arc sine of 5π/3 we can't do, but we can do it if it was the arc sine of the sine of -π/3, which is the same angle. So there's our answer. negative pi over 3. That was a tricky one. Now the arc cosine, or the cosine of the arc cosine, they would cancel each other out, but pi is about 3.14. It doesn't exist. Remember, for sine and cosine, we have to take a number between -1 and 1. That's greater than 1, so we can't do it. It does not exist. Let's do some more of these. We're going to be seeing a lot more of this in the next chapter as well. So if you're not getting it right now, we're going to be doing more practice, and hopefully it'll clarify as we go through. The tangent of the arc cosine. Now, these are a little bit different. What we're going to do is we're going to find the inside first. The arc cosine of 2/3. It's a positive and it's cosine. We're going to draw a triangle in quadrant 1. Here's theta. Now the cosine, adjacent over hypotenuse, 2, 3. Since we're in quadrant 1, they're both positive. Now we can find the missing side using the Pythagorean Theorem. 2 squared plus b squared equals 3 squared. 4 plus b squared equals 9. B squared equals 5, so b equals the square root of 5. And now we're just going to find the tangent of that angle theta. So the tangent, opposite over adjacent, root 5 over 2. It's all about drawing the triangle. And there we go. For number 28, we're going to find the arc sine of -3/5. So we're going to draw our triangle. Since it's arc sine and since it's negative, we're going to be in quadrant 4. So there's our triangle in standard position. Sine, opposite over hypotenuse, 3, 5. Now, since we're in quadrant 4 and our hypotenuse is never going to be negative, the 3 has to be a negative. Using the Pythagorean Theorem, or if you know right away, it's a 3, 4, 5 right triangle. I'll show the Pythagorean Theorem. 9 plus b squared equals 25. B squared equals 16, so b equals 4. Once again, we're in quadrant 4. X is positive, y is negative. So now we just find the cosine. Adjacent over hypotenuse, so it's going to be 4/5. And there is our answer. Now let's do a couple different ones using the same thing. I'm just going to up the difficulty a little bit by using some x's. Now the arc cosine of 3x, and they're telling us that x is between 0 and 1/3. That way we're not taking the arc cosine of a number greater than 1. That's why this added restriction is there. So now, they're telling us it's between 0 and 1/3, so it's going to be a positive number. I'm going to put my triangle in quadrant 1 because that's when cosine is going to be positive. So now if we look, cosine, adjacent over hypotenuse. Our adjacent would be 3x and our hypotenuse would be 1. So we need to find our sine, we need to find the opposite. So Pythagorean Theorem, a squared plus b squared equals c squared. So what we have here is 3x squared plus b squared equals 1 squared. So that's 9x squared plus b squared equals 1. Subtract 9x squared from both sides. B squared equals the quantity of 1 minus 9x squared. Take the square root of both sides. B equals the square root of 1 minus 9x squared. We're in quadrant 1. We're going to keep the positive angle. So now, sine is the opposite over adjacent. So for the sine of theta, it's going to be opposite the square root of 1 minus 9x squared over 1, or the square root of 1 minus 9x squared. We don't need the 1 in the denominator, so there it is. Now, to find the cotangent. Now, we're looking at the arc cosine of 3x, same thing. So we can use the same triangle that we used in number 29. So now, the cotangent. Is the reciprocal of tangent. So cotangent is adjacent over the opposite. So the adjacent is 3x over the square root of 1 minus 9x squared. Now we shouldn't leave it like this. So what we should do is we should rationalize it. So we could leave it like this, or we could rationalize it by multiplying by the square root of 1 minus 9x squared over the square root of 1 minus 9x squared. So the cotangent of theta, 3x times the square root of 1 minus 9x squared over 1 minus 9x squared. So we could write it either way. And let's just make sure that we're okay with our domain. 1 minus 9x squared has to be greater than 0. Because we can't have 0 in there in the denominator, because we can't divide by 0. So what we do is we subtract 1 from both sides. Negative 9x squared greater than negative 1. Divide both sides by negative 9. X squared less than 1/9. Take the square root of both sides. X is less than 1/3. And that's when we have a restriction that's a little bit different, that it's less than. It can't be equal to, because if it was equal to 1/3, it would cause division by 0, which is no good. All right, thank you. And we'll have one more section left in chapter 4. Have a nice day.